Okay, exponents and exponential functions review. We've got our test coming up Friday. Hopefully this review helps you out with that. We'll get straight into this, starting with number 6 here, number 1. Chess tournament starts with 64 people competing. This exponential function here describes how many people are remaining in the tournament after X rounds. How many rounds will pass until 2 people are remaining. So I don't know what X is, but I need to find what X gives me 2 people remaining. So when does that 64 to the 1/2 power of X equal 2? So in other words, this is telling me that Y equals 2. So I would suggest using Desmos for this. You want to type in that equation, which is 64 to the 1/2 power of to the X power. It gives you this little curvy graph here. If I want to know when 2 people are remaining, I graph Y equals 2. Find where they intersect, which looks to be right there at 5, 2. So after 5 rounds, there are 2 people left in this chess tournament. So that will be 5 rounds. Another way of thinking of that, it's starting at 64 and halving every round. So it goes from 64, 32, to 16, to 8, to 4, to 2. So 1 round, 2 rounds, 3, 4, 5 rounds. Whoa, 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 whoa. What happened? There we go. 5 rounds, that is answer choice H. Number 7. Determine the amount of an investment of $500 if the account earns 8% interest each year for 12 years. We haven't really talked about investments and all this, but all this is an exponential function. Start with $500. It is gaining 8% interest. It's going up 8%. We need to add that to 100 to get 108. Convert to a decimal. 1.08 to the power of X. So that is our equation. Y equals that. After 12 years, we are going to plug in a 12 instead of the X. So if I can calculate that using either your calculator or Desmos, I'm going to go with Desmos here. 500 times 1.08 to the power of, now if I wanted to graph it, I would put X. Well, the power of X. That'll give me the curvy line, which is way over there. It's gaining up there. It starts at 500 on the y-axis. I don't care about the power of X, though. I want the power of, was it 12 years? I don't remember the problem. Yes, 12 years. So we have 1259, $1,259. Choice D. Number 8, biology. This equation, they give you the equation, represents the number of bacteria in a culture after T days. How many will there be after 6 days? Take the equation, 5, and just plug in a 6 for your T. 10 times 2.5 to the power of 6. That's a Desmos calculator. 10 times 2.5 to the power of 6. 2441. Yeah. Number 8, find the domain and range of the biology problem above. So we're taking that equation, this here, and I'm going to graph that. I have to see a picture of the graph before I can figure out what the domain and range is. So sketch a very rough graph of that. It starts at 10, because that's my A, and the growth rate is 2.5, so it's growing. So there's 10 right there. That's where it starts. And it grows upward. Domain is left to right. wall to wall. Here's my left wall. There is no right wall. So everything greater than 0. So domain, all the x values greater than or equal to 0. Equal to because of the solid dot. It starts at 10, this bacteria thing, and then it not starts at 10. Yeah, it starts at 0 days it was, and it grows 1, 2, 3, 4, 5, 6, on and on and on. Every number higher than 0. The range is the y values, the heights, the floor to ceiling. Floor is at 10, and it goes up forever. So the y values are everything greater than 10. There's your domain and range. 9A, depreciation. $60,000 piece of machinery depreciates. That means it loses value at a rate of 11% per year. So A times B to the power of X. We have A is 60,000. Don't type your comma in. Times B, which is your growth rate. It's losing 11%. So that means it is 89%. Convert that to 0.89 to the power of X, but it says what will its value be in 5 years. So we're going to say to the 5th power. So I'm going to type that in Desmos there to get the value of this machinery, 60,000 times 0.89 to the power of X, not X, to the power of 5. So $33,504. C. 9B, find the domain and range of that graph. So again, we've got to sketch it. It starts at 60,000 because that's my A, and it's depreciating. It's going down. So I'm going to make 60,000 up at the top, and it is losing value, or like that. Domain, left to right, wall to wall. Or we can think of it differently. Domain is the time along the bottom. The range is the value on the y-axis. So the time that this piece of machinery will be here is, well, it starts at time 0, whenever it was made, I guess. And it's going to go on and on and on indefinitely. I don't know when it's going to be gone, so I just assume that it's going to be here forever. So all of the years greater than or equal to 0. The range is the dollar values, all of the values that this machine could be worth. Well, it starts at 60 and it goes down. So range, we're looking floor to ceiling. It's everything in between 0 and 60,000. So 0 is less than y is less than 60,000. I know it equals 60,000 at the beginning, and the asymptote down there, it will never equal 0, so we leave the equal to off of that. Number 10, what is the domain, range, and asymptote of this exponential function? Let's start with domain. Wall to wall. X goes forever to the left, expands up forever to the right. All real numbers. A range, floor to ceiling. It looks like there is a asymptote right there. The ceiling of this function, it looks like it goes up forever, so there is no ceiling. So it is every y value above, I think I'm missing a line here, but above -2. So it's all the y values greater than -2. Now, I know it doesn't equal -2, so I'm not going to put the underline there, since that's the asymptote. The asymptote here is the equation of this blue line, of the floor. So the equation of that horizontal line is y equals 0. That's my asymptote. It's was the equation of the boundary line. I know the curve never touches 0, it never equals 0, but the actual boundary line is y equals 0. Not 0, what am I thinking? -2, usually 0, down 2 units. Number 11, this is what we did on Monday. I know there were a few of y'all not here Monday, so this is very important because this will definitely be on your test. We have to take the data in this table and figure out what the equation is, and then use that equation to figure out when this ice pack will reach 5 degrees or less. So start with putting this in Desmos. The way we put that in Desmos is we click this plus sign up here and add a table. So 1, 2, 0, 1, 2, 3 was my x's. 0, 1, 2, 3. My y values, or my temperatures, 73, 50.4, 36.3, and 26.1. 26.1. So it plots those points in, it's hard to really tell, but if I kind of expand this view, you can see that it's sort of decreasing in a curved pattern there. It's going to look like that. I need the equation of that curved line. So the way Desmos can give that to me is, I want to tell it to, I'm sort of typing in y equals ab to the power of x. It's not going to be just like that. I want it to use the y's from the table up above. I'm going to call it y1. And instead of equals, I do the squiggly, approximates a times b to the power of x1. It's going to use this data, this x1 and y1 data, and figure out the best a and b that it can to create that equation. And you can see it graph the line on there. A is 72.6, b is 0.70, 0.71 if we're going to round it. 0.7 we'll call it. So if I come over here, A was 72.6 times 0.7 to the power of x. I want to know when this equation will reach below 5 degrees. Not -5 degrees, not 5 degrees below 0, but just when will it drop down below the 5-degree mark. There's been some confusion there. I don't know the number of hours it will take. I don't know the x, but I do know that I want y to be 5 or less. I'm going to go add into this Desmos graph here, y equals 5. So that's the red line that marks 5 degrees. If I just look and see where these two cross, which is right there, after 7.7 hours, it'll hit exactly 5 degrees. So I'm going to say about 7.7 hours. So that, I think, is very important, that you're able to find the equation. This is almost like a whole second question added in there, is to use that equation to answer different questions. So make sure you can get that equation. In other words, make sure you know how to do that process right there, that y1 squiggly, ab to the power of x1. Will be on your test, guaranteed. On the back, we're looking at all exponent rules practice, starting with FOIL, or double distribution. There's a lot of these problems, and they're the same type of problem. I'm not going to go work through every single one. This first column, working all the way down, is one problem of each type. I'm going to work number 12, then I'll give you the answers to 13 and 14, and you can check yours. This is FOIL. First, outside, inside, last. So we're going to take the first 5x times x, and get 5x squared. Outside, or the outermost terms in those binomials, 5x times 4 is 20x. The I stands for inside. I want to take the inside, which is negative 2 times x, and then last, negative 2 times 4. Every single problem, every single FOIL problem, you'll have like terms in the middle. 5x squared plus 18x minus 8. There's your answer there. And here's 13 and 14. 13, make sure you know that this squared means to multiply 2x plus 5 times itself. Rewrite it to look like a FOIL problem. Number 17, we have division here. Our division rules tell us to divide the big numbers, or the coefficients. 75 over 25 is 3, and subtract the exponents. X to the third, x squared. If I subtract 3 minus 2, I get x to the 1 power. I don't need the 1 up there, I can leave that off. Y, negative 3 minus 2 is negative 5. So y to the negative 5th does not go up top like that. That's not fully simplified. We're going to move that to the denominator and make it positive 5th. So there's that one. Same rules apply to number 18 and 19. Here's 18 and 19. I do want to point out one thing on number 18. There's no b's up top, and on the bottom you have b to the negative 2 power. Normally I tell you when you have a negative exponent, move it to the bottom, make it positive. Well, here it's already at the bottom and negative. We need to move it to the top and make it positive. So that's why b squared is in the numerator in our answer. Another way of thinking of that is imagine b to the 0 power up top. If the rules tell you to subtract, 0 minus negative 2 is positive 2. So b squared would be moved up top. Number 20, this is a multiplication problem. The multiplying rules tell me to multiply the coefficients to get negative 8 and add the exponents. X to the invisible 1 and invisible 1 is 2. Y to the 7th because of 3 plus 4. And then 21, 22, we have these answers here. 23, power to a power. Our rules tell us to apply this squared to the negative 4. So negative 4 squared. If you type that in your calculator, you've got to use parentheses like I wrote it here. Just type in negative 4 squared, you're going to get negative 16, which is incorrect. Negative 4 times negative 4, positive 16. Multiply these exponents. A to the 2 times 2 is 4. B to the 3 times 2 is 6. 16a to the 4th b squared. Be very careful with the negative number squared. Anytime you square a negative number, always has to be a positive answer. And there you got 24 and 25. Negative 216 y to the 15th over x to the 6th. A to the 4th, b to the 16th over 16. 26. We have multiple steps going on here. Here I see power to a power being multiplied by power to a power. I'm going to do this first, then that, and then multiply those answers together. And actually 27 is the same way. 28, multiplication on top, multiplication on bottom, and then divide. Back to 26 though. 4a squared b, parentheses squared. I square the 4, give me 16, multiply the exponents. A to the, A to the 4th, b squared. Times, now I have the right part. Negative 5 to the 3rd power is negative 125. A to the 9th, b to the 9th. Now I have to multiply these two together. If I take 16 times negative 125, I get negative 2,000. I'm adding my exponents here. A to the 13th, b to the 11th. So here's 27 and 28. Multiply, or x power to a power first, then multiply. Here multiply, then divide, and those are your answers here. Moving down to 29, 30, 31, 32, these are just systems of equations. We learned substitution, we learned elimination, and we learned how to graph these on Desmos. It doesn't say how to solve it, so I'm going to say Desmos will be the easiest way. All you're going to do is graph that equation in Desmos along with that equation and find their intersection point. So let's start with y equals 15x plus 4. Get rid of all this other stuff we used. Y equals 15x plus 4 and y equals 5x plus 34. I see the 2. I don't know why this, ignore that 5 comma 2. That's needs to go away. There's the intersection point. That's where those two lines cross. That's the x and y that they both have in common. If you remember back to when we originally learned this, I can plug in 3 for my x and 49 for my y in both equations. So x equals 3, y equals 49. That can be plugged into both equations at the same time, the x and the y. It's the only set of numbers that can work in both at the same time. So 3 comma 49 is your solution. The next 3 are going to work the exact same way. Just go to Desmos, plug it in, get your ordered pair where they intersect. And here's 30, 31, and 32. So I just went to Desmos, I graphed all those, found the intersection point. Save some time, I didn't show all that, but there's the last one, 32. Be very careful with this. Double check that you graph these correctly on a test. If you just use the Desmos method and get it wrong, I will not give you any partial credit. It would be either all right or all right or all wrong. If you show your work using substitution or elimination, that's how you would earn partial credit. But just be careful that you type everything in. Double check to make sure your equations match, and Desmos will never fail you. Good luck.